Welcome to the Anna-Mena video tutorial. My name is Robert Pitzpahl and I'm one of the two directors of the Institute of Solar Research at the German Aerospace Center. We are here at a very special site, the Plataforma Solar de Almería in southern Spain. And at this site, the whole story began about 30 years ago. 9 countries started the endeavor to show the feasibility to create solar thermal power from concentrating collectors as a future alternative to fossil fuel. The project was very successful, the feasibility was shown, but at that time, solar energy was still significantly more expensive than the fossil fuel alternatives. In particular, Spain and Germany started to join forces and transfer this facility to a research center, the Plataforma Solar, with very many different facilities in order to improve the components and reduce the cost. CIEMAT, the Spanish institution in energy research, is today the owner and operator of this facility. 2 demonstration projects have been erected and tested and were very successful. They showed the feasibility of producing electricity from this resource. This is a very large facility with many different options and opportunities. And we are part of the whole story to reduce the cost of the electricity by doing joint research together with CIEMAT and also with industrial clients. Most of the experiences that has been collected throughout the past is now recorded and part of the Anna-Mena video tutorial. How to operate the facilities, how to measure the components are essential parts that has been collected here and now provided for the information in order to transfer this knowledge of solar energy applications also in other countries. There's also a strong need for solar power in your country. What you see here in the background is one of the newest facilities here at the Plataforma Solar, the Contas rotating platform. It has been erected in the last year together by DLR and CIEMAT and is jointly operated on a 50-50 cost-shared basis. The platform serves to test the components of a parabolic trough collector, the mirrors, the absorber tubes, in order to qualify these for the industrial clients. DLR and CIEMAT can independently serve their industrial clients on a confidential basis, and the facility provides high accuracy performance figures for these components here. It's a rotating platform so that the incident angle of the sun can be adjusted exactly the way it should be. The measurement of solar radiation is, of course, very important in order to assess the solar facilities tested here at the Plataforma Solar. In addition to have accurate devices, which are highly sophisticated and need a lot of maintenance by scientists, these sensors are much more robust, and they will be, in the future, brought to potential future sites for solar thermal power plants, for example, in the Sahara Desert. So by calibrating these systems here, parallel to the high sophisticated devices, we can achieve a reasonable accuracy. And the devices themselves need much less maintenance, so they can be operated unattended in the desert area for about a year and collect the weather data there in order to give the information whether the potential site is suitable for a solar thermal power plant. That are the basis for the decision on where to erect and construct a solar power plant in the future. What you see here in the background is one of the largest facilities here at the Plataforma Solar, a full parabolic trough collector loop. It's very similar to the loops that we have in commercial parabolic trough systems, with one major difference. Instead of using thermal oil as heat transfer fluid circulating through the absorbers, here we try to take water and steam directly. This has the advantage that it's much cheaper and higher temperatures can be achieved. On the other hand, there's a significant challenge. Water and steam are separated in the flow, and they are not providing homogeneous coolings in the absorber tube. So it's a major research task to operate such a system. This work has going on for more than 15 years now and was very successful, as we see now first commercial applications of direct steam technology in the market. But there is still room for more improvements. So the facility right now is changed and modified in order to even more simplify the process and come to higher temperatures and more efficient systems. So in the future, direct steam generation systems can become even more competitive and cheaper. Yeah, other than the facilities you have seen before, this one operates in a different manner. You see many two-axis tracking mirrors that concentrate their sunlight on the top of a central tower. This technology has a chance to achieve higher concentration ratios, as we have a point and not a line focus. And by this higher temperatures, more efficient processes can be driven. On the tower there, you see several test platforms so that different experiments can be operated in parallel in order to investigate the heat transfer of the concentrated radiation into the heat transfer fluid. Other than just heating up a fluid, like a molten salt or a steam mixture, but also the integration into a chemical process. By that, solar energy can be used in order to store the energy chemically and to create a solar fuel. One example is the generation of hydrogen. This requires very high temperatures of more than 1000 degrees centigrade that cannot be achieved in parabolic trough systems. So also for this purpose, we use the central facility, which you can see here.